Now we're going to start this video by looking back at an example from a previous video. These husky sled dogs in the last lesson. And when you do the independent practice, you'll notice that all of the questions that we ask you to answer, about percentage, give you nice numbers that seem to fall exactly on +1, +2, or +3 standard deviations, right? So when we ask you which percentage of dogs fall between 47.7 and 54.9 pounds, those seem like very specific numbers, but they are just line up exactly with these percentages that we know about +1, +2, and +3 standard deviations. But what if I wanted to know what percentage of dogs fall between, 49 pounds and 56 pounds? And those numbers don't line up with our exact +1, +2, +3 standard deviations, right? It's going to be some between -1 and -2 standard deviations, and 56 is between +1 and +2 standard deviations, kind of somewhere in between. How do we figure out the answer to that question? Well, what we want to do is we want to normalize our data, or we want to standardize our data, right? So we're going to look at now a standard normal distribution. Before we were just doing normal distributions, now we're going to do a standard normal distribution. And what that does is it turns all of our means into 0 and our standard deviations into 1. Okay, and the way we do that is by calculating something called a z-score. Okay, and a z-score is our standardized value that tells us how many deviations we are away, or standard deviation we are away above or below the mean. So we can take any data point and we can turn it into a z-score and kind of standardize it on this new normal distribution. So you'll notice that this distribution looks very similar, but is slightly different than the last normal distribution that I gave you. Because here, instead of saying mu, we're just immediately calling that 0, right? And this, instead of this being, 1 sigma, 2 sigma, 3 sigma, it's just 1, 2, and 3, right? And we want to fit our data point, more numbers that in between 0 and -1, right? And between 0 and 1, and between 1 and 2. So that's what these z-scores do. So we need to know how to calculate a z-score, and a z-score is calculated with this formula here, which is a little hard to read on my paper. So we take z is equal to, x, which is our data point, and we subtract mu, and we divide by sigma, right? And mu is our mean. This also could be x bar. I'm probably going to end up using x bar. Again, we're using those interchangeably in this course. And sigma is our standard deviation. Okay, so these problems can be a little bit tricky, so we're going to break this up over 2 lessons. And this lesson, all we're going to do is we're just going to figure out what the z-score is, and then read a z-score table. So that's just the idea behind this lesson today. All right, so let's start with just something kind of straightforward. Let's talk about determining a z-score. Okay, and then we'll see how it fits in with this curve and how we can use it to help us solve problems. So we have a formula. Z equals x minus x bar over sigma. That's it. And remember that x bar is the data point that we're given. How does that compare to the mean and the standard deviation? So we just plug these guys in. So z equals 250 subtract 200 divided by 25.4. Get our calculator handy. 250 subtract 200 is 50 divided by 25.4 is 1.97. And normally I'd say you can write all the decimal places, but that's not going to help us now. We always want these guys rounded to 2 decimal places, okay? And that'll make sense when we look at the table. Again, here's another problem. Pause the video, try to do it. Okay, So Z equals X minus X bar over sigma. And so we've got 17 as our data point, our mean is 18, and our standard deviation is 2.2. So thinking about what that means, 17 is really close to 18, right? Especially with a standard deviation of 2.2. So we should get, thinking about what kind of z-score we should get. So 17 subtract 18 divided by 2.2 is negative 0.45. Okay, so now what do these numbers mean? A z-score of 1.97. We are almost 2 standard deviations above the mean. A z-score of negative 0.45 means we are almost half a standard deviation less than the mean. Okay, that's what those z-scores represent. They're not just numbers, they're telling us how many standard deviations we are away from the mean in our standard normal curve. Okay, so we need to be able to calculate a z-score. We'll talk about how to use that, in a problem a little bit later. Okay, my notes are a little bit different than yours, so I just wrote down the next question that's in your notes is what percent of the data is to the right of z equals 1.96? Okay, so what does that mean? Let's go to our picture here. Z equal to 1.96 means z is almost 2. Okay, so what percent of the data is to the right means above that. So from this part of the curve, it's asking how much data is in that part of the curve. Well, how do we figure that out? We have a table that will help us. And some calculators have this programmed into them. Some programs have them calculated or have them kind of programmed in. We're just going to use a good old-fashioned table. So if you look in the very last pages of your notes, I'm going to zoom out a little bit, you're going to find this table, the standard normal distribution table. And it looks a little intimidating, but I promise it's not terrible. Okay, so these numbers on the outside here, these bolded numbers, are our z-scores. Okay, and you'll notice that if the table comes in 2 pages, there's all the z-scores up to negative 0.09, which is, really close to 0. And then on the second page, we start at z-scores 0.00, which is 50% of the data, which makes sense, right? Because in the standard normal distribution, our mean is 0. Right? It's exactly in the middle of our data, and so our mean is 0. So it's 50% of the data is below it, and 50% of the data is above. So these numbers on the outside here tell us z-scores. The numbers on the inside tell us percentages, but they're written as decimals. So what percent of data, and you'll notice you get a little bit of a clue up here. It's always showing you percents to the left. So when you get a z-score and you read it on this table, it will tell you how much data is to the left of it. And left means less than. Okay, so if you get a z-score of, let's say, negative 2.81, okay, z equals negative 2.81, that means you're almost 3 standard deviations away from the mean. So we look at z equals negative 2.8, here's 2.81, okay, so this is the percentage of the data to the left of that. So that's 0.25%. percent of the data. It's a very small amount of data, and that makes sense because in our curve, 3 standard deviations is way over here, so we don't have, you know, we're almost at 3 standard deviations, so we've only got a little bit of data to the left of 3 standard deviations. Okay, if I wanted to know how much was to the right of that, that's all of that data there. So I would need to I'd need to take 100% and subtract 0.25%, which is 99.75% of the data is greater than that data point that gave us this z-score. Okay, it's a little bit tricky to kind of figure out, but let's see what it means in that problem in our notes, right? What percent of the data is to the right of z equals 1.96? So we need to use the second part of our table where all the z-scores are positive. That's a really common mistake. Students kind of forget that this is a negative 1.9, so we want to use a positive 1.96, right? Because there's our 6, 1.96. So when z equals 1.96, we get 97.50% of our data is to the left. Okay, this question asks us though, how much is to the right? So we can take 100% and subtract 97.50, and we're going to get 2.50% of the data is to the left, or sorry, is to the right, sorry, to the right. Okay, which means only 2.5% of the data has a z-score higher than 1.96. So that means that only 2.5% of the data is above 1.96 standard deviations away from the mean. Okay, that can be really complicated. So take some time, go through your independent practice, and make sure that you are trying to read this table and checking your answers and then asking me questions if you need anything. There are a couple of questions that ask you to look in between. So what's in between, put 0 here, what's in between negative 1.51 and 2.51, right? So negative 1.51, we've got 0.0655. Data is to the left of that, and at 2.51, here, 2.51 is 0.9940. That means that 99.40% of the data is to the left of that. So how much is in between? Well, if you take this number and subtract this number, then that'll tell you how much is in between, tell you how much is in that part there. Okay. This looks much more complicated than it is. It's just kind of something you need to try and maybe come back and watch the video again or ask me questions about. Okay, good luck, guys.